We are Seraphim.
Welcome to Generation Space, the podcast by Seraphim, the world's leading space tech investor. Tune in to learn about what space tech is doing right now to address the world's most pressing problems like climate change, food security, and ubiquitous connectivity. Find out how the space tsunami is disrupting every industry on our planet. Space is a $1 trillion market opportunity to which investing in will secure a better future for the planet and all its inhabitants. Food shortages, ubiquitous connectivity, and climate change are just a few of the huge problems facing our planet today, and we need solutions fast. Space is no longer just the playground for the mega-rich. It's time to stop looking up and wondering. We need to start looking down and understanding what space tech is doing right now and how we can leverage the technology to save the planet. Space has a genuine capability to drive towards net zero. There's no way that net zero can be achieved without harnessing the potential of space tech. I'm Leah Martin, and over the course of the next 10 episodes, I'll be taking you on a cosmic journey through the space tech ecosystem, introducing you to some of the key players, the brightest minds, and the most innovative companies in the business. Today we'll meet Mark Boggett. He's my boss, and he's founder of Seraphim Space. Mark is a pioneer in space tech investment. He co-founded Seraphim Space and has led many of the investments into the current portfolio, which include 3 companies that have already achieved billion-dollar valuations. Mark will be in conversation with Will Whitehorn, chair of Seraphim Space Investment Trust. Will is director of AAC Clyde Space, who build microcube satellites, and he sits on the government Space Exploration Advisory Committee. Formerly, Will was a director of Virgin Group, president of Virgin Galactic, and ex-president of UK Space. What these two don't know about space is probably not worth knowing. So, Will, let's get straight to the point. Why space? Why now?
I think a long time ago we learned, even from the time of the first Sputnik launch, which is 1957, that satellites could be very useful for humanity. We quickly started using them to communicate, and indeed there was an Olympics and indeed a World Cup being broadcast live by satellite by the early 60s. We also realised that we could use satellites to observe the Earth and learn about it. I think really the first true evidence of climate change came as much from space as it did from any ground observation. But space was always held back. It was held back from being truly industrialised by the fact that governments built all the rockets and they'd been geared towards the military and the then Cold War that was going on. And slowly but slowly, commercial technology and people like communications companies and other sorts of companies started to change that. But the big bang has come recently.
Absolutely, Will. Yes, it's really Mr. Elon Musk we've got to thank for heralding a new era of space in right now. Through SpaceX and their reusable rockets, he's really driven down the cost of sending a kilo into space. So to put this into perspective, it used to cost in the 1980s $86,000 a kilo, and now we can send through the Falcon 9 rocket a kilo into space for less than $1,000. So that's really opened up space to the commercial environment. Now, at exactly the same time, we've seen a revolution in the satellite industry. Satellites that you would think of when you conjure a satellite to mind is the size of a car or the size of a bus. It costs hundreds to billions of dollars. And those type of satellites are now being surpassed by a new form of satellites that are being put together by entrepreneurial companies that are taking components from other adjacent sectors. So they're taking components from the smartphone industry, from consumer electronics, oil and gas, the automotive industry, and they're bolting these together to build smaller, lighter, cheaper, more capable satellites. So many of these satellites are now capable of achieving functionality, much the same as these satellites that traditionally cost hundreds of millions of dollars. So if you bring those two things together, low-cost launch and low-cost miniaturized satellites, we're now in an era where it's possible to build satellite constellations of hundreds or even thousands of satellites.
So Mark, from a Seraphim perspective, can you explain to everyone the investment opportunity in space and why now is the time to get involved?
So what we just described there, these thousands of satellites that are being launched to create a digital infrastructure in space. Let me just put this into perspective. To date, there are only 13,000 satellites that have ever been launched to the end of 2022. And there are only actually 5,000 satellites that are operational in space today. And yet we see a future where there are hundreds of thousands of satellites that are creating together to create this digital infrastructure from space. So now genuinely is the time to be investing in these companies that are building this infrastructure and providing this new capability to our planet. So this covers a whole range of areas, from climate and sustainability, through telecommunications, through mobility or autonomous mobility. There's smart cities, food security, general security, and those are just the core themes that are being driven by this digital infrastructure. We've also then got all of the end industries that are going to be impacted and disrupted. Industries like insurance, industries like oil and gas and logistics, real estate. There really isn't a terrestrial sector that isn't going to be impacted by this data and tsunami capability from space.
Yeah, I think that's what people don't realise, do they? That it's already happening right now, for example, GPS.
I think one of the key things is that we've already got to a stage with the oldest piece of the new space technology is the GPS system. It was only unlocked in the mid-1990s by the US government, and yet it has revolutionised not only when you want to Google where you're going in a street sense, or you want to use your sat-nav in the car, you see it personally every day. But of course, what it's also doing is making sure that food doesn't spoil in ports anymore. It's making sure that a robotic tractor pulling a piece of harvesting equipment in Brazil can have no human operating it, and it can use less fuel. The GPS system is believed to have already saved billions of tons of fuel being burned around the world needlessly because things have had to go the wrong way to do things and can't be as accurately tracked. So that's just the beginning of the new space revolution that Mark's talked about. It was the earliest thing really to be unlocked. And what we are seeing with the current generation is new types of technology in space, like hyperspectral cameras and AI-enabled radar in space. These things being used on satellites are allowing this revolution that Mark's talking about to be a really precise one as well.
Let me just pick up on that to give you some examples. So, for example, it's possible from space to look down at a farmer's field and identify the moisture of the soil. So that means that you don't need to water the entire field. You just water the part of the field that requires water. That preserves the precious commodity of water. So from that exact same infrastructure, it's also possible to look down and identify what the bad actors are doing, the individuals and the companies that are chopping down rainforests, polluting our rivers and our seas.
Even right down to, in fact, Mark, they can tell an individual chimney that's producing CFCs in the Far East from one that's actually not producing any of the pollution it shouldn't be producing under international law and UN agreements now.
Mark, I'll go to you first. What excites you the most?
Yeah, it's the sheer volume of data that's going to be available about our planet. And really, it's the fusion of these different data sets that are going to be able to help us really understand the heartbeat of the planet and to be able to use this data to, one, better manage the planet so that we can use resources more efficiently and to address many of the big issues that we have in relation to climate and sustainability.
And what about you, Will? What excites you personally?
I think the thing that always excites me is the future. Through what is currently going on and the kind of companies that Seraphim's investing in now, you can also point a way to a future whereby we get a much greater industrialization. You know, if you've studied economic history, there's always a point, an inflection point, where things take off. One of the early historians covering industrialism called it the unbound Prometheus, when suddenly you just get this roller coaster effect. And I very much feel that, especially when we look at the kind of companies we're working with at Seraphim, that we're right in the beginning of that phase. So we are seeing an economic takeoff. And of course, the easiest way to see that is the projection of the number of satellites over the next few years. That alone is really exciting. That is definitely a hockey stick. And the hockey stick of other industries developing in space is just around the corner.
I think just to build on what Will was saying there, the way that we've characterised this opportunity, first of all, is about space looking down at planet Earth and using this infrastructure to be able to monitor and manage everything that's going on Earth. That's $1 trillion investment opportunity right now. If we look a little bit further into the future, maybe 5 years, probably not 10, we're then looking at an environment where we're actually building on top of this infrastructure. Now, this is about lifting dirty industries from our planet into space. Industries like the data center industry, which is highly pollutive and getting worse, taking that activity into space. It's around pharma and biotech, finding new discoveries in a zero-G environment. It's about providing energy from space, solar farms in space. So there's a huge amount of activity that's going to go on building upon this infrastructure. And all of these things are going to be hugely beneficial to our world, but they're also going to be massive investment opportunities. We see these next type of developments as another $1 trillion market opportunity this market has to offer.
Without any doubt, you can only say that the future for space is definitely only going in one direction. And that's because, of course, behind everything that we're talking about here is the population pressure in the planet itself. So we know that before population growth stops, we're going to get to 10 billion. And everybody from Isaac Asimov to Professor James Lovelock to Stephen Hawking all said that when population got to that kind of level, that space industrialization would be underway, because it's the only way we'd ever get to net zero at that point.
Just so people can get their heads around it, what's happening right now?
Let me explain a few of our portfolio companies. Let's start off with our largest portfolio company, ICEYE. So this is a company that we invested into before they put any satellites into orbit. They're now the world's largest constellation of radar satellites. So what's a radar? Well, a radar satellite allows you to be able to look down at the ground, at planet Earth, in very high resolution, regardless of whether it's day or night, and regardless of what the weather is and the amount of cloud coverage. That means that you can reliably look at the ground under all conditions 24/7. So what ICEYE are doing is they're building out a constellation that's large enough to allow them to be able to look down at planet Earth and every square metre of planet Earth every hour, and then run change detections over planet Earth for every hour, every 3 hours, every day, every week, every month, every year. Think about the huge amount of data that's being collected with that activity and how that's going to have an impact and be highly disruptive across a whole range of different industries. Where they're focused at the moment is the insurance industry. So the insurance industry is being badly hit by climate-induced extreme weather events, the fires, the floods, the tornadoes. So, for example, in flooding, what ICEYE are able to do, in real time as a flood is occurring, they're able to identify the extent of the flood, the depth of the floodwater, the speed of the floodwater. But importantly, they're also able to identify which assets are being flooded, which houses, which cars. They are then able to provide this information to the insurance industry as a source of truth. This is exactly what actually happened on the ground. So then the insurers can then use that data to evaluate claims and make payouts. That reduces significantly the costs of insurance, and it means that the payouts can occur quicker. This is making the insurance industry more efficient and responding to the climate-induced weather events that they're subjected to. But the same technology can also identify that family that's needed to climb onto the roof of their building because their building's being flooded. And the same technology, by providing this change detection on an hourly basis, can then be used to identify from a humanitarian effort where that family is located so that they can be helped and supported.
Also, Mark, I think one of the exciting things that you've introduced me to is the concept of actually managing the new air traffic control for drones from space. So one of the investments that we've made is in a company that is part of that process itself. So you might want to talk about that a bit.
Yes, this is a company called Altitude Angel, a company based in the UK, and what they have is an air traffic control solution for drones. So that links to the airline industry so they can identify what is going on with the commercial flights, but then also allows them to manage a virtual highway for drones to be able to fly up and down, stacked on top of one another. So they have recently won an award here in the UK to run a 264-kilometre virtual highway, joining 8 cities. So this includes the postal sorting office. So there's a huge implication for how this kind of technology is going to impact our everyday life.
My view is that we're going to get to a stage quite quickly whereby we no longer think of space and the atmosphere in the same way. We just think of it as a seamless industrial process helping humanity to survive. And it won't be 50 miles is NASA's definition of space or 100 kilometers is the Russian definition of space. It'll be actually space begins in the ocean and ends at the edge of the universe. And more of the work we do, which is dirty and bad to that slightly sealed part of space, our atmosphere, will move outside it. And less will be done inside it so that we can live in this very safe cocoon called planet Earth. I think The future for space is so bright because the technology is now available and that technology can be taken to space. As Mark said right at the beginning of this podcast, the revolution here has been access to space using miniaturized technology we'd already developed for planet Earth. And from there, we will see this full-scale industrialization in the future. And actually, it's a much brighter future, I think, than most people realize at the moment.
Okay, Mark. Okay, Will, thank you for that. That was absolutely fascinating. I thought, just for a little bit of fun, I'd ask a couple of myths. So, first myth, rockets are terrible for the environment. Will?
I mean, it is a myth. Rockets are saving our environment. Again, if it wasn't for these systems we've been talking about, we wouldn't even know the extent of climate change, and we wouldn't know how to manage our process to get to net zero. But the most important fact, remember, is all the rockets launched every year, even with the projections over the next few years, will be much less than a day's flying in terms of any environmental impact. And a day's flying is now much less than the effect of all the server farms providing us all with Netflix films every night.
Let me put that into more perspective. So a single launch of a Falcon 9 SpaceX rocket is little more than the equivalent of a 747 flying from London fully laden to New York. So that's the kind of carbon emissions that we're talking about from a single launch.
Yeah, people obviously don't realise that, and people are flying thousands of times a day, so that's fascinating.
As Will just said, a single day in Heathrow is more than the entire year's worth of launch.
So next myth, space is full of junk.
Again, on the generality of that, there have only been 4 major incidents that have caused 97% of the junk, 3 of which were deliberate. The other one was a bad accident, which probably could have been prevented. And the most recent of them was the Russians hitting a satellite, which obviously caused the International Space Station to have to divert its orbit, which people might have remembered a couple of years ago. But that is the reality of it. We're not making much more space junk, and we're now starting to clean it up.
Yeah, so really there's about 500,000 pieces of individual junk in space today. That sounds like a lot, but actually consider space similar to our own oceans. At any one point in time, there's millions of boats on our oceans. If you think about the equivalent as we scale out on planes into space, the issue today is to ensure that that doesn't get any worse. So we've been making a number of investments in order to focus on this particular area. One was an investment through Leo Labs, a US company we invested into, that's able to, from some radars based around planet Earth, look up into space and identify an object the size of a penny from 1,000 kilometers away, travelling at 17,000 miles an hour around our planet and capturing all of these in real time into a database that enables the operators of satellites to be able to use that data to be able to avoid any oncoming collision. And Will mentioned that one of the accidents there that's happened in space in the past could have been avoided if this kind of technology solution and data was available at that point in time. The other thing is that there are now companies that we've invested into that are actively removing debris from space. So we're really trying to clear up the past littering of space, but much more importantly, to make sure that future operators in space don't have this throwaway culture. What this is leading towards now is an acceleration of the regulatory environment to ensure that space is capable of continuing to be commercialized. So the regulators around the world all really have the same objective, which is to make satellite operators responsible for their satellites once they've reached the end of their economic life or that they have broken down whilst in space. So now there are a range of companies out there like Astroscale and D-Orbit and others that an operator can contract with in order to remove their broken or end-of-life satellite. And what they actually do is they propel them back down towards planet Earth, where they burn up in the atmosphere, rather than continuing to operate in space and then subject to potential other debris collision.
Now, when we say burn up, they atomize back to their original atoms, so no debris falls to Earth. What we want to avoid in space is large chunks of debris coming down as well, because one day that could potentially impact on humanity. So that's one of the top priorities. And we have to face the fact as well that the biggest threat in terms of debris in space is military activity by governments. And that will have to be regulated as well. At the moment, there is no real regulation of military activity in space, apart from an old UN treaty, which means you can't use nuclear weapons in space. And that will be the next stage, hopefully, of the UN's work on regulation, not only regulation of the commercial sector, but also trying to forge a treaty not to commit acts of war in space, because that will be the way that we end up destroying our ability to use the area around the planet, because that will create debris on a scale which commercial activity will never have any chance of doing.
But regulation is catching up with the developments in space.
I think the regulator is now being given the tools to enable them to be able to regulate effectively. Previously, they didn't have the data to understand the extent of the debris problem. Now they do. Previously, they didn't have the tools to force operators to remove broken satellites. Now they do. So now I believe that we're in a position where the regulation can be accelerated. I still think that it's a number of years away, and I fear that it's going to take an event in space to catalyse the regulation around the world. But I do believe we're a handful of years away from this. And actually, all of the participants in space are actively wanting this regulation in place.
Brilliant. I think that's what a lot of people just don't understand that. And people hear that in the news all the time and it frightens people about space. Last myth, there is no water in space.
It's a myth. There is water in space. We know there's water in space because we've actually seen it now. It can be in the tail of comets. It can be in other objects moving through space. And of course, we know that the other planets, Mars, for example, has water on it. And we know that the moon has water on it. And we know without any doubt that there are probably trillions of tons of water even within 1 billion miles of Earth.
Yeah, let me put that into perspective. 1 billion light years away, there's been identified a very significant vapour cloud of water, equivalent to 140 trillion times the amount of water that we have here on planet Earth. So it's an absolute myth that there is no water in space.
What I've heard in the news that through the Artemis missions, there might be something called ice on moon ice. Can someone explain that a little bit more? I think people may have heard about that.
Well, there is definitely ice. Whether or not we can access it easily in a usable way is the next question that's going to have to be answered. In Mars' case, we know we'll be able to access it if we establish a mission to Mars because it's much more discernible. There's also frozen carbon dioxide on Mars, which may be very useful for humanity as well. But the fact is, with the moon, it's going to be bringing it together into a usable amount in that environment of having virtually no atmosphere and virtually no gravity. But there's definitely water up there.
So almost using the moon as a stepping stone to explore the wider atmosphere.
Undoubtedly.
Thanks, Mark. Thanks, Will. Thanks for joining me today. A really fascinating discussion. You've been listening to Generation Space, the Seraphim podcast. If you'd like to find out more about any of the topics we've covered today, then check out our website.
We are Seraphim.